To my rozpoczynamy, a nie Państwo. Wtedy, kiedy jesteśmy gotowi, to... Hi, Juri. No właśnie. To są takie parę drobnych ruchów. Ty potrzebujesz tą lampkę? Na głowę. Bo możemy też czasami, wiesz, wyłączyć światło górne i zostawić tą lampkę. No, popatrz. A mnie się tutaj bardzo długo przekierowuje na YouTube. Zgodnie z przypuszczeniami na Zoomie mam bardzo dużo ludzi. Ale to dlatego, że zapowiedziałem, że czynne uczestnictwo w wykładzie daje możliwość zadawania pytań, chociażby tym osobom, które nie mogą być na zajęciach. No i tyle. Cześć. Aż trudno rozpoznać, kto jest kto. To mam prośbę do Państwa. Jak macie Państwo telefon komórkowy, wejdźcie na stronę studia, jeżeli Wam jest znana. sme.amus.krakow.pl. W ten sposób będę miał potwierdzenie, że leci już stream. Ale ponieważ są sami zaprzyjaźnione osoby, to, że jeszcze nie rozpoczęliśmy otwarcie, to jest nasza norma. Będzie jeszcze nie. Zobaczcie, powinno być takie okienko na stronie studia i ono powinno już streamować. Ja to robię przez Zooma, czyli uruchamiam Zooma i z Zooma przekierowuję na YouTube'a. No i stream leci na YouTubie, przy czym osoby, które w tym... To nie jest twoja grupa chyba do końca. Właśnie. All are quite gentle. They muted their microphones. Czy jednak to znaczy, że się zaczęło? Nie ostrzegliśmy Państwa, ale się zbliżamy.
Użyłeś kiedyś OSC przez tą sieć?
Wiele razy. Ale wiesz, tak, zgodnie z moimi opowieściami, z doświadczeniami ostatniego tygodnia z najnowszym komputerem, to już niczego nie jestem pewien. Rosetta 2 i tak dalej. To są wchodzimy w takie klimaty, które... No tak, ale to jest ta... No właśnie szukam jakby sposobu na tą 32-bitowość, która zniknęła całkowicie.
Ale to nas już jakiś czas.
Nie, to ja wiem, zawsze można powiedzieć, że mówiono, przecież mówiliśmy ci od lat, że zniknie. Nie, wiesz Marcinie, ja po prostu używałem starego systemu świadomie.
Tak.
No i po to, żeby jeszcze używać rzeczy, których dawniej nie używałem, a to jest taka polityka, która no, niejako wymusza na wszystkich zmianę, a w moim przypadku albo w wielu przypadkach wyrzucenie pewnych kanałów, pewnych aplikacji. Ja na jednych zajęciach pokazuję rzeczy, które zginęły bezpowrotnie na przykład i I one dalej są. Jeżeli masz ten stare urządzenie ze starym systemem, to możesz pokazać niezwykłe projekty, które kiedyś funkcjonowały przez ileś lat. No i teraz są niedostępne, czyli ja mogę je tylko pokazać studentom, albo im zaproponować, żeby za 150 zł kupili starego iPhone'a na przykład i uruchomili taką aplikację. To jest, no ale to wchodzimy w taki dość mocno alternatywny świat, prawda? No i to, co proponuje Apple, ja daleki jestem od krytyki, bo jakby świadomie kupiłem ten najnowszy model, ale równocześnie dobrze jest mieć takie spojrzenie na te wszystkie alternatywy, które są wokół. Jest z nami Juri Bulka, który był przez wiele lat do tej pory, jest specjalistą od tego rodzaju, a troszeczkę mi zamarł na ekranie.
Mogę tu przymknąć?
Tak, nawet należy. Ja się właśnie stamtąd przeniosłem.
Marcin, to jest taka, że jestem podłączony oboma urządzeniami do tej samej sieci.
Mhm. Ale się nie widzą. No a ja zwykle robiłem tak, że uruchamiałem na swoim komputerze sieć, po prostu swoją wewnętrzną.
To nie działa z Androidem.
Aha. Mam drugiego iPhone'a, jak chcesz.
A masz touch OS?
Tak.
Bo zwykle to ja przywożę swój router, tylko że ja jestem
dobra.
na wakacjach. Powiedzmy.
Znaczy, to co, uruchamiasz swoją lokalną sieć?
Tak.
Do której się...
A, bo myśmy w internet się wyłączyli.
Znaczy, no wiesz, mnie się ta AM pojawia. No, potrzebujemy chwili czasu, żeby ona się pojawiła, więc dlatego. Bo w moim przypadku we wszystkich tych performansach, gdzie używam jakichś urządzeń poprzez Wi-Fi, no to uruchamiam na komputerze swoją sieć lokalną i do niej pinguję po prostu i z nią się łączę. I wtedy jest jakby pewne, bo niezależna od tych sieci, które są wokół. A to wiesz, to bardzo różnie bywało w przeszłości właśnie w różnych
Tak. Problem jest taki, że ona jest pewna, jeśli też jest czasem tak, że się nie da do niej podłączyć, ale chodzi o to, że Androidy, bo to nie jest sieć normalna, to jest sieć ad hoc. I Androidy niestety się z sieciami ad hoc nie łączą.
No jasne.
To zróbmy tak.
Bo mamy kilka alternatyw, według mnie.
Aha.
Jedna to jest taka, że ja jeszcze Państwu nie przedstawiłem tą osobę, ale tam jest na zewnątrz jest plakacik.
Jeszcze nie ma.
Jeszcze Ciebie nie ma, tak, jeszcze jesteś. Jest sporo osób angielskojęzycznych, więc to będzie taka próba, żeby przełączyć się na angielski. I pytanie do wszystkich Państwa, czy Państwo nie macie przeciwko. Więc, tak, jest okej. Jak trzeba będzie, to się przełączymy zawsze z jakimiś wątpliwościami na język polski na chwilę. Także macie Państwo jak najbardziej prośbę, żebyście Państwo pytali, jak coś będzie niezrozumiałe. No i wracając do naszego dylematu, przedstawiamy Ciebie, przedstawiamy historię DxArts, wiesz, i wydaje mi się, że tutaj mamy bardzo dużo rzeczy do powiedzenia. Ja wiem, że plan jest główny taki, żeby pokazać jak najwięcej rzeczy praktycznych, prawda?
Trochę.
Natomiast możemy to właśnie w ten sposób podzielić na dwie części.
Dobra.
Żeby ruszyć z miejsca, no to właśnie zaczynamy od tej części takiej bardziej opisowej. Jeżeli jesteś tam podłączony do sieci, to masz to pokazać. Potem robimy krótką przerwę. Ja w międzyczasie w sposób subtelny podaję Ci swojego iPhone'a, prawda? No i tyle. Znaczy ja tylko powiedziałem o swoich doświadczeniach, że ja zwykle się łączyłem w ten sposób, że mam na 11 kanale w Macu swoją własną sieć i z nią się łączę.
No, a
I wtedy jestem bezpieczny.
I też się z nim łączę. I tak.
No tak, ale nie ma tego routera w tym momencie, więc jesteśmy na takim poziomie. Tutaj też są sieci. Jeżeli byłaby jakaś inna sieć, no to jesteśmy w stanie się połączyć.
No, alternatywą byłoby to, że jest jakaś inna sieć.
Wszystko jest takie problemy.
Chodzi o to, że ma być integracja.
nawet fall 2019.
Tak, tak. Przenosimy się w czasie.
Mhm.
Sobie.
No to ponieważ ja tam już leci, to bardzo serdecznie Państwa witam. Bardzo się cieszę. Pierwszy wykład w nowym roku, rok 2022, chyba, tak? Dobrze policzyłem? Tak, 2022. Jest, tak, ten weekend. Witamy się z Państwem, którzy są w studiu. Wszyscy są zamaskowani. Niektórych rozpoznaję mimo tego. Jest z nami Marcin Pączkowski. Marcin Pączkowski, który jest członkiem zespołu studia na wyjeździe. Jest niejako delegatem studia na Northwest, bo to jest, tak jest opisany rejon w Stanach Zjednoczonych wokół Seattle. Tak jest. I pamiętam, że pierwsza uczelnia, którą odwiedziłeś, to był Central Washington University w Bennesburgu. 2 hours drive from Seattle. No a potem odbyłeś w drugą stronę, czyli na zachód podróż i jesteś w tej chwili w samym Seattle. University of Washington to jest ta chyba największa uczelnia tam.
No w stanie.
W tym stanie. Tak, mówię o stanie Washington. No i to, co jest ważne, o czym już parokrotnie mówiliśmy, tam na tej uczelni jest ważne centrum założone przez Richarda Karpena chyba w 1989 roku, tak mi się wydaje, DX Arts, czyli Digital Arts and Experimental Media. To jest tak, znaczy ten skrót jest troszeczkę mylący, prawda? Bo tak. Nie da się znaleźć po prostu tych 4 członków w samym skrócie, czyli cyfrowa sztuka, o tak bym powiedział, bo DX Art będzie najprościej skojarzyć z cyfrową sztuką, może extended, to X to może być
to właśnie Digital and Experimental Arts.
Okay.
To było takie, ale inaczej się nazywa.
So I think this is the crucial moment, the right moment to switch to English.
Sure.
Because Marcin Pączkowski, jeszcze bardzo ważne, Marcin Pączkowski is quite important to remind his background because he graduated Academy of Music in Kraków with 2 diplomas, conducting and composition, but also very active as a saxophone player, as a programmer, and much more. So I think I mentioned about those 4 topics, the most important topics.
Yeah, I think so.
We can check. Yeah. So your turn. Thank you very much.
Thanks, Marek. Hello, everyone, ladies and gentlemen. It's great to be here and do this ad hoc presentation for you, which we set up 3 days ago, 5 days ago, something like that. So I work, currently I still work at the University of Washington, where I did my PhD, and my focus is on live computer music, on performing with computers. I do a variety of things, as Marek mentioned, but here I'll be, But here I'll be showing you work with I'll be showing you 2 things, well, more things, but I'll be showing you a little bit of my own work with focus on Super Collider, which is an environment for mostly for computer music, for making computer music.
It looks gone. Yes.
And I'll show you 1 or 2 videos of my work, and then we'll try to set up something with actual motion control using a phone if we get them to connect over Wi-Fi. Because as I said before I was here, or before we started, I do use sensors connected over Wi-Fi. Typically not phones. I make my own custom sensors using microcontrollers. I program them myself. But the most reliable way to do this is to always have your own Wi-Fi router, and this is what I always do for performances. But again, I was not planning on performing, so that's why there's a little bit of lack of preparation on my part here. So maybe what should I start with? Maybe I'll start because we are switching to do the practical things later. I'll show you some slides about the controllers that I have prepared for fall 2019. And then we'll look at those videos, and then I'll actually show you some simple examples in Super Collider so you have an idea how it works. And then finally, maybe we'll be able to actually control it using movement of a phone. If there are questions at any point, feel free to interrupt me and ask or translate or anything. Let's keep this informal. As I said, here are some slides that I've used in the past for showing motion sensors. So we're gonna just go through them really quickly to give you a frame of reference. One of the, maybe before I start, with my work with computers, I was always interested in the performative aspect that's similar to the paradigm of conducting. Because I am a conductor, I conduct classical music as well as current new contemporary music, but I was interested in using using. Great, thank you. In using the conducting like gestures for controlling the computer. So the frame of reference of the controls I'll be showing are related to this kind of control, controlling like an ensemble, controlling the tempo, controlling overall structures, more, but not only, but more than controlling maybe individual sound. Although there's an overlap definitely. So the one of the early examples is Radio Baton, developed by Max Matthews, the father of computer music. This is, you can see it's a baton, it's a stick that is being operated over a table, and the proximity and the touching of the sensors in the table sense the touch of the stick and its position. And this way, Max Matthews is able to conduct pieces. If we have time later, maybe I'll show the video.
Mostly classical repertoire.
Yeah, I mean it's quite funny actually. Let's.
Bill,
Oh, there's a wrong note there. This was.
C minor became C major.
I was actually curious. That note, that chord, the C major there is actually present in early editions. It was later corrected. So it's not a mistake necessarily, but if someone took music and didn't know the performance practice or later editions. So yeah, so Max Matthews, this is really charming, but not necessarily the kind of performance I'm after. But this is really important as a where we're coming from. The control paradigm is there. I did mention motion sensing. Mostly, I am using sensors called accelerometers that measure acceleration. Acceleration, which is the rate of change of movement. Fortunately, we have gravity, and that's why you can use accelerometer to some extent. You can use it to sense tilt, because if we were to operate accelerometer in space, in deep space. If it's stationary, it would read 0 in all directions. We tilt it slightly, and if we stop it, it still reads 0 in all directions. Because we have gravity, we detect that constant pull along different axes. But this gets complicated because if we move it like this, how do we detect this movement, or rather this movement, from holding it like that, where we are also pulling on that axis slightly? But these are we are getting into the weeds a little bit, but this is what I need to face, or what I'm interested in researching when I program my own sensors, because I program them for, well, not for exact movements, but I have an idea for a movement, and then I try to figure out how to sense it. If the movement is too fast to be sensed, then I'm trying to reprogram the device to sense the movement. It's not like that, well, the phone doesn't send the data fast enough, then we have to do something else. No, I go in and I change the sensor, or I change the rate of messages to be able to detect movement exactly where I want it. That's why I'm referencing these controllers where these researchers, inventors, composers were facing similar problems and were working around them. So as I said, I work mostly with accelerometers, and I was really excited about my frontier work in 2013, 14. Well, I knew I'm not the first, but I felt it's kind of new and fresh. And later I found out that the first that I know, use of accelerometer dates back at that point, it was like over 40 years. So nothing new here, but in 1972, accelerometers were
50,
72, well.
50, 71.
Yeah, but when I started 2012,
okay.
13, so at that point it was like 40, 47.
Yeah.
Yeah, at the time, accelerometers were much more expensive, much more bulky, easier to break. Right now, it's a chip. Yeah. This device, this is 3 centimeters by 2 centimeters roughly.
Mm-hmm.
So this sits on my palm. And the sensor itself, if you order like 10 of them from China, it's like $2 a piece or $3 a piece. So it's much easier to obtain these days. So, but not a new idea. Merce Cunningham, his dance company, used accelerometers, analog accelerometers, which, as I understand, were fed wirelessly into FM synth to change the timbre from the dancer's movement. Quite cool, considering how that technology worked and how bulky it was. Do you know more details about it?
No.
Yeah, because I couldn't exactly find like the exact documentation, but from what I read, for instance, this is what it sounded like, that they were transmitting their signals using like a regular wireless microphone radio or some other kind of radio, and then feeding them into analog synthesizers for controlling synthesis parameters and modular synth.
But it's written 72, which is kind of a discovery of John Chowning, the FM synthesis used for sound synthesis. And the first piece is 69. This is his first piece. It's much earlier, before Yamaha DX7, which comes 11 years later.
That's a good point. So maybe
market.
It wasn't even FM. Maybe
there was
else.
Another additive synthesis or subtractive.
Or some kind of LFO using as a controller. But as I understand it, they use it in the synthesis patch directly. That signal was used in synthesis patch directly. skipping forward about 2 decades, and actually one slide for 2 decades and then 2.
Ja zapytam po polsku
Other day.
tutaj Państwa, czy Państwu jakby w ogóle temat jest bliski, bo to tak wchodzimy dość szybko, głęboko w sterowanie gestem, zamiany go na różne stosowane systemy. I no dla mnie jest to bardzo przejrzyste. Natomiast wydaje mi się, że to jest taki punkt, nie to, żebyście Państwo natychmiast co parę sekund zadawali pytania, ale
Tak,
może będzie
nie
taki
zgubić
moment,
się.
jak Państwo macie już poczucie tego, że jesteśmy w jakimś kosmosie, w jakiejś przestrzeni.
Przez chwilę byliśmy.
Tak, to proszę nam dać znać.
Bardzo
Jesteśmy
proszę.
tutaj Państwu w stanie może pomóc. No wiesz, Piotrze, bo to są Twoje zajęcia, więc ja tak mówię, ja na to zwracam uwagę chociażby z punktu widzenia, no wiesz, rezultatu takich. Wykład jest wykładem i my to streamujemy i nagrywamy, także będzie to umieszczone na stronie studia, także będziecie Państwo mogli do tego wrócić. Ja Marcina poproszę o przesłanie PDF-a z aktywnymi linkami, to co ja zwykle robię,
Jasne.
bo to wtedy jest jakby możliwość wręcz powrotu do tych nawet przykładów, prawda, konkretnych, wtedy jest łatwiej. Przepraszam za takie...
Nie, dobrze.
Ja
Nawet
mam
takie pytanie,
cały czas za mną chodzi ten dylemat.
Tak, właśnie bardzo dobrze, bo nawet takie pytanie, ale że jak to? Może uda nam się coś naprowadzić, jeśli Państwo gdzieś, jeśli to nie ma takiego sensu, bo właśnie chodzi o to, żeby tą ideę przedstawić, to nie tam, że wszyscy rozumieli tam ten akcelerometr czy ten, ale żeby właśnie to, jak to działa tak intuicyjnie, więc proszę przerywać jakby co. All right, so let's look at a couple of videos here. The first one, Letizia Tsunami, it's a project from the 90s with the glove device, which has sensors on it, and it. Yeah, I think these two basically have a similar, if I remember correctly, have a similar number of controls. So the gloves sense bending of fingers. This is sensed with a so-called bend sensors. There is a acceleration detection, which is used to detect tilt and movement of the hand. And I think Letizia Tsunami's glove has a built-in mic because she's doing like a vocal performance with recording things. And Imogen Heap, is an artist who's still active. I mean, they are both still active, but Imogen Heap is more recent. Her project Mimio Gloves is a project. These are commercially available, if quite expensive, unfortunately. And these also have bend sensors. They have accelerometer. What else is there? There's a button. They developed software for to allow connecting the glove to a variety of other softwares. So you can, from that software, you can send MIDI from the glove. So it's like a middleware, kind of a middleware software that allows you to control, for example, a sequencer or a software synthesizer directly. You connect the boxes and create mappings. So this is how the software looks. So here you see yaw is an input from the yaw is a one of the three axes. So input from accelerometer is mapped to MIDI controller 7. Another interesting thing about that software is that you can train positions. They call it hand positions or hand poses actually, and they are detected So you can have a signal when you do this. You can have a signal when you do this. You can have a signal when you do this, which by itself, it's not very useful, but it allows you to do something like this. And then you move and nothing happens. And you grab it again. And then the signal is only sent when you actually make the pose like this or like that. So the combination, the software allows for combining these triggers and sending them directly to some other software as MIDI or as OSC. Again, her performances are really nice. So instead of me talking about them, let's look. Okay, I have a couple of them.
These gloves. Some people don't even know that I make music, but they know about these gloves. So these gloves are called the Mimi gloves, and I've done a lot of touring in my life, and I've had to carry around a lot of gear with me. And sometimes I just want to do something really simple, like I want to record my voice, or I want to add some reverb, or I want to like tweak something that I'm playing on a synthesizer. In order to add change a filter sound, like makes me go wow, or maybe I want to pan something around the room. And in order to do that, if you're panning something around the room and you're not using gloves, you have to use what's called a pan pot. And so you have to go left. And when you're on stage, it's not the most expressive thing to do, to go like eek, eek. So I was just hankering so much for be able to kind of reach into the software that I love inside my computer, but without having to stand next to it and having to look like I'm doing my emails when I'm making my music. So what we have here, and I'm just going to test it's working. I've just got my, I'm not going to use my effects here. So you might be able to see on the camera, but not you. But over here, you can see fist, puppet hand, open hand, one finger point, two finger point, secret finger, pinch.
These are the poses that I mentioned.
And you can choose whatever postures you want. We developed this software called Lover. And you can also see lots of things kind of moving around on the screen. And essentially, I'm like kind of like an airplane. I've got pitch, I've got yaw, and I've got
Torba mnie fascynuje.
so combining these.
Nie, zobacz jak jest ubrana, ma taką torbę.
Down, left, right, kind of specific points that you can reach. And then you also have accents, so you can hear like this, and slap. Just like that. So yeah, so I'm going to sing you a song, but first of all, I'm just going to demonstrate. I won't go into too much detail, but I've essentially got different scenes in here. So you can like have different mappings that will access different things inside my software. So basically, right now I am going to just like do this, and then I am recording my voice. Do this, and then so I've made a loop. I do this. You might hear it's a bit over there. I am recording my voice, and a bit over there, and then I am recording. And then I'm going to delete that just by dropping my hand, so it's not there anymore. But I can record it again. I can record it again. And then let's go. And so when I often do this, and I actually did it in when we were rehearsing, and I forgot that I didn't have my gloves on, and I still did this movement, which has become second nature. So when I want a reverb, I go into secret finger, and then over here, secret finger is 0, and when I go over here, really long reverb, and I've got reverse on my right hand. Right hand. Doesn't make sense that way.
So as you can see, this is very experimental. Of course, she's playful with it, and she's developed it, and you use her for her music, and it's very effective.
Ciekawe miejsce, Marcin, zobacz, tam pianino stoi, jakiś sklepik, znasz to miejsce?
So this is NPR is a national public radio in the US. They created this series of concerts. I think it's even pre-pandemic, Tiny Desk Concert, and you submit a video of musicians submit video of themselves playing behind a desk. Like it's meant to be like really small and intimate, and they choose the best ones they want, and they present them in this kind of informal space. So it's like she's going to be behind this. There's a desk. So it's like it's desk and it's meant to be like a like an office with books. So yes, it's a whole series. So I will send that link. I recommend it. I recommend you to look at her performance. It's quite charming, really. So yeah, my unfortunately will go downwards from here. But before, there's also one more video, which I think it's quite entertaining. The crowd's response. Yeah, so a lot of many possibilities there. Of course, most of them was just a harmonizer or like a pitch shifter that plays the harmony. But if you add the ability to change it without touching anything, that can be quite effective in a variety of musical paradigms, let's say. Since we are kind of going backwards, let's do this. Now I'm gonna show you one of my projects with this kind of technology, but it's yeah, as I said, it's going to go downwards from what we were. This is a piece for percussionists and one drum, mostly one drum, and motion sensors. And what you're gonna see here is playing on the drum itself, recording that playback, but also triggering sounds. There's a the system is set up. The system is set up into various scenes throughout the piece. But one of the scenes is where the percussionist plays on the drum, where he gets an acoustic sound, and then he plays a virtual drum or plays in the air, where the sensor detects the hit, and instead of the acoustic drum, just the synthesized drum is being played. But the system works the way that when he plays the real drum, the synthesized drum is not being triggered. And that's done only by comparing the trigger from there's a contact microphone on the real drum. When there's a trigger from the real drum, the artificial drum does not respond. So he has two drums, with one of them being acoustic drum and the other being electronic drum, and he can just play it like that, and that works quite reliably. So let's this is excerpt, and listen to the whole thing. Yes. In this piece also the some of the transformations were being controlled by the tilt of one hand while during the sound processing. There was a granulation process, and I will try to recreate some of that here. We'll see how successful we're gonna get in a moment. And the final video I want to show you before we move to the Super Collider part is something that I've done kind of on the spot for a presentation for some kind of a tour at our department. And I realized that people enjoyed it, so I made a little video. Maybe not to Max Matthews in a way. All right, where are we here? Yeah, this is how the my own sensors look like. On that one video, I did use that Mimio glove because our department got it, so I was able to play with it. But the motion sensing looks roughly similar between these various sensors. So should we try transitioning to the Super Collider? Okay.
We can make a short break.
Sorry? Break? No break? No break.
Well, it's up to you, Marcin.
No break. I will show you a little bit of Super Collider. And then we'll see if we can get the connection to work.
I have to touch OSC as well.
Yep. Sorry?
No, ja mówię, że ja mam na iPhone'ie też Touch OSC, jakby,
Tak,
bo cokolwiek to
od ciebie mówię.
ściągnąłem ostatnią wersję, także.
Super. This is a nice demo here. Let us put this server. Oh, forget. This is the Super Collider environment. You can see this is the code window where we actually create write code that's being evaluated and then sent to the synthesis server. What I wanted to show you is just a simple way of creating a cloud of sound. So I already booted the server. Super Collider consists of two main parts. There's a scripting language with an interpreter, which is like JavaScript, interpreted in real time, where you write a code, you can evaluate it line by line or section by section or a full file. And then there's a synthesis server which runs natively at a full speed. They talk to each other over OSC locally, Open Sound Control Network Protocol. They talk locally within the computer between the language and the server. The language defines the processes, how they are connected to each other, sends that information to the server. The server actually processes the audio and makes sound. They can also run on a separate computer, so you can have a scripting part on one computer and the server running on a different computer, on a computer that's in a different room that's more powerful or runs in different country over the internet. This is an example with a bunch of code blocks, and where I'll show you a simple maybe synthesis with sinusoids. This is what's called a synth definition, synth def in short. It has a sine oscillator at a frequency that we define as an argument when we call it, amplitude that we define as an argument when we call it, also pan that we define as an argument when we call it. It has a little envelope, and it's a percussive envelope of I think it's a fixed duration of 1 second. If I play it, it's 440 hertz percussive envelope. I can run a routine and play it 10 times. Not terribly interesting, but 10 sinusoids. Now I'm going to change the frequency randomly for each of those 10 times between 440 and 450 hertz. So you can hear it's changing. Let's increase that range. Starts to sound like something. And here we maintain that range of frequencies, but you see the wait time between each synth was set to 0.2 seconds. Now we're going to add randomness to this value. So it's 0.1 second plus a random value between 0 and 0.5 seconds. And the same thing faster, because it's 0.01, so 10 milliseconds, and the randomness of 0 to 50 milliseconds. And the upper, let's do the upper range the same as before, but faster. And now we also do it 100 times instead of 10 times. Let's increase that range as it was before. Maybe that was a little too high. Oh, this is why I did it. Okay, this is. That randomness is not the best kind of randomness for frequency control, because we perceive frequencies exponentially, and this is a linear distribution of frequencies. So that's why it's top heavy when we hear it. But that's okay. This is already a cloud that's different than that for the simple sound at the beginning. But now let's do something over time. Here I am using an argument which is going to change by 1 for each of the iterations. So we have 100 iterations again, and this will change from 0 to 99 for each subsequent iteration. So what we can do with this is to calculate the frequency for each of the nodes based on that increasing number. So this is the lower portion of the random generator will go from 40 to 99 times 20. Well, 100, maybe 100. Well, 99 times 20. So a little under 2000. So it will go from 40 to 1959 or something like that. And the upper bound will go from 450 to something like 4,400. Again, the same tempo. The same idea with less of a change because I'm multiplying that number by 5 instead of by 20. But faster, and there's 1,000 of them. And this is just from that one sound. So this is a demo. Does that have some kind of does it make sense in any way? What I meant to show here is that with just few lines of code, you can create a whole gesture that potentially changes over time. So essentially, what we have at the end is just these 5, 6 lines, and these 1, 2, 3, 4, 5, 6 lines. And what I could do is also change the randomness for the volume. So the volume is also randomized. Now it's going to be between -38 and 24. At this tempo, it's not very audible, so let's do it more dramatic. You can hear some of them are louder, some of them are quieter. All right, so now we gradually transition to that part where I'll try to set up the communication between Super Collider and Pączkowski. Mark, may I?
Yes. Okay. No, chcę się do tego, już zrobiłem to moje.
Ale możemy zrobić disable.
Ale to
Idziemy.
coś mówił, że ja muszę mieć.
Okay.
Tak, jak się włączy. No tu coś jest. 190, no coś będzie jest 18.
Tak, jak masz tą sieć UDC, to tam i też uzyskujesz te dane.
Tak jak to nie był adres IP. No ja coś tu musiałem włączyć, żeby to się w ogóle pokazało. No to spróbujmy przesunąć sieć AMEM jeszcze raz. Może z iPhone'a to pójdzie, chociaż nie widzę dlaczego.
Ja byłem, już się zalogowałem.
AM?
Tak.
No dobra, no to teraz na AM mój adres to...
Jesteśmy? Tu zapisujemy.
Wszystko się zgadza.
Jest!
No to
Dobra.
super. No,
No dobra, no to próbuję. To słuchajcie Państwo. Okay, so going back here, I have a little document I started setting up. This is already booted. Set up buses, buses for accelerometer. So now this is the receiver for my OSC messages. I can see the OSC messages I'm getting. You can see them here. XYZ. This is the address. Stop posting that. And here I set what's called a responder in Super Collider, which will read those messages, and it will set a control bus according to those messages. So now I have a stethoscope that shows oh, that's interesting. The range of that is different than on Android. Now, yes, X, Y is the second one. Y and Z should have a reading of 1. I don't know which direction. This direction. Upside down. All right. So this works. So we have our little motion sensor here. So I'm going to record some sound. Oh, I know. Okay. I'll make sound. I'm not sick. I'm just making sound. And it looks like this. Just 2 seconds, just to prove that I recorded something. I'm going to play it back. Really short. That's fine. That's fine. I can play it as twice as fast. And I can also. Oh, look at that. All right. So now we're going to granulate that. So we're going to make little we play subsequently. Let's increase the grain rate. And let's move through the buffer faster. Even faster. Or can randomly granulate the whole buffer. That is, sure. And finally, something I have not tried before because I ran out of time, but to make this all controlled from this, I'm going to replace the position in the buffer with the motion, with the
Nie wiem, czy nie poszedł w sleep.
Sorry?
Nie wiem, czy nie poszedł w sleep.
And just like this directly. To map the range. This is the beginning of the buffer with the click. I cannot quickly plot you exactly where we are, but I'll show you what I'm doing. I mean, you'll see what I'm doing. We are here, here, here. And the final thing, let's change the pitch of that with tilting of the phone. So the rate is here between 1 and 1. We're going to map the. Actually, we can directly do this. So accelerometer Y, and this is -1 to 1. -1 to 1. We're going to map it to 0.5 to 4. Splitting. So that's going to.
To Marcin, tylko może wytłumacz, co to jest ten Touch OSI, prawda? Bo to też ważne dla Państwa.
Yeah, so we're using an app that sends the messages from the accelerometer that's built in the phone, sends it over Open Sound Control Network Protocol. We've managed to finally connect it. So
Using Wi-Fi connection, not Bluetooth.
Yeah, it's Wi-Fi, yes, Wi-Fi connection. So yeah, it's sending these the 3 axis, and as I showed you here, you can
X,
see
Y,
them.
Z. Mhm.
The second one is Y, first one is X. So this second one still thrown back, and the bottom one is Z. So if I flip it upside down, it goes up. And of course, if I move it like that, it goes crazy.
Jeszcze temat takiej no, dopasowania danych do parametru, którym sterujemy, bo to jest też taki temat, który się pojawia na początku, jak się używamy tego, prawda, że często one nie są akuratne, prawda, że jak sprawa skalowania. No, bo to wydaje mi się, że tutaj działa to idealnie, ale w wielu wypadkach jest tak, że te wszystkie drgania na przykład przenoszą się też na te parametry, które mamy, ale często nie jest to korzystne.
Tak, tak. No, tutaj właśnie robiłem skalowanie, bo parametry jest, wydaje mi się, że parametr gravity force, czyli jak Państwo widzą tutaj na trzecim wykresie oś Z ma wartość taką stałą, to jest właśnie, to jest wartość 1, jak jest w środku, to widać, że całość jest wypełniona. Więc te wszystkie te, we wszystkich trzech płaszczyznach mamy wartości od -1 do 1, jeśli tylko używamy jakby statycznie telefonu, bo jeśli go no, poruszymy mocniej, to oczywiście on jest większym przeciążeniem niż 1G, ale jeśli jest statycznie, no to tylko jakby ciąg 1 w płaszczyźnie Z, albo 1 w płaszczyźnie X, albo 1 w płaszczyźnie Y. X, Y, Z. I ja tutaj, zakładając, że właśnie takie wartości mamy, potrzebowałem to przekonwertować. Tutaj jest pozycja w pliku i ta pozycja powinna być od 0 do 1. Lin to jest funkcja, która mapuje jeden zakres do drugiego, więc tu mamy wejściowy zakres minimalna wartość, maksymalna, czyli -1 do 1 jest mapowane do 0 do 1. Także ja już tu te wartości jakby dostrajam.
Czy podobnie jak obiekt scale w Maxie, prawda? Czyli
tak.
Przekładamy jedną skalę na drugą.
Dokładnie.
Czyli rodzaj transkrypcji danych.
Tak, a tutaj przekładam -1 do 1, znowu, żeby mieć tą pełen zakres, na 0,1, czyli 1/10 prędkości odtwarzania, jeśli chodzi o zmianę wysokości, do 4, czyli 4 razy szybciej odtwarzania, czyli 2 oktawy.
Jasne. No to oczywiście tych parametrów jest dużo więcej, ale tak w takim, bo to wydaje mi się często jest związane z tym tak zwanym bouncing, wiesz, w tym, że sterujemy na przykład jakimiś mediami, sterujemy jakimś kosmosem i nagle ten kosmos cały drży i już ucieka nam to wrażenie grawitacji właśnie, która zamienia się nagle na jakieś drganie bardzo minimalne. I podobnie jest z dźwiękiem. Że wszystko drga na przykład, prawda? I dopiero musimy go odłożyć, wtedy jest stabilne. Bierzemy ręce i wszystko jest rozstrojone.
To właśnie Państwu zaprezentuję tylko szybciutko taki problem, jak może być. Tutaj podłączę jeden z tych akcelerometrów bezpośrednio do częstotliwości oscylatora. Coś tam jeszcze potrzebujemy. Słyszą Państwo takie przejścia? No właśnie tego nie chcemy.
Czyli jakby zmniejszyć system.
Można zmniejszyć, ale w tym przypadku to raczej trzeba wygładzić. Bo słyszymy te przejścia, jakby schodki częstotliwości. Możemy to wygładzić. Możemy to wygładzić taką komendą lag. I schodków już nie ma. Drży, ale wygładza po prostu. Nawet wygładzić tak, że będzie dużo wolniej. No i bez wygładzenia, żeby... No i co, no 12:09 to taką sinusoistyką
tak.
kończymy?
To ja mam jeszcze takie
Proszę.
No w sumie, gdybym nie miał 2 dzieci, to pewnie jak dzisiaj wróciłbym do domu, to starałbym się nauczyć sobie.
Piotrze, bo mamy trochę osób na tym, jeżeli możemy dalej, bo jest trochę osób, którzy nie rozumieją po polsku, więc jeżeli możemy zostać przy angielskim, to też będzie pomocne dla wszystkich.
Chcę. Pytanie, after coming back home, probably I would like to start to learn Super Collider. And can you like tell students, I mean, is it very difficult what you've shown, or how much, or just, you know, discuss Super Collider from this point, like learning and then getting to such a level, or creating this sort of patch, or
Sure. I mean, getting to this level of coming up with these things on the spot took me. I started learning Super Collider in 2009.
Mhm.
After a year of classes, I haven't been using it for maybe 6 months, and I sat down and I didn't know where to start again. So I started looking through my class materials, and it started coming back. Few more months, I started being able to write code without just modifying the examples. So you will be modifying examples and changing things before.
Go to tutorials.
Yes, and there are on Super Collider website, there are some resources. You can.
I can answer to your questions, Piotr, also, because we've been coming back to Super Collider many times. We have some intensive workshops, but there are still several people in Kraków, which are.
I'm not.
If we are interested, we can
I
extend
was
it.
not talking about myself personally, but
Okay.
like
Yeah,
the
how
voice
you
of
get into it, sure.
students, I guess.
Mhm.
I hope.
Yes, on the our documentation and website and everything, it's not the best, but we are improving it. I mean, shameless plug. I've been the release manager for the last couple of releases of Super Collider. I've been contributing to the project, so I'm really kind of involved right now. People are coming and going. If you go to the Super Collider GitHub page, github.com/Super Collider, in the README you can see some Eli Field Steele's video tutorials are really nice. They are on YouTube, publicly available. The Super Collider comes with a help browser. Where there's a tutorials here. It shows you how to do basic things. Not only basic things. So Super Collider comes with help with tutorials. There are materials online. The caveats with learning Super Collider is that there are typically more than one way. There's more than one way of doing certain things. So you might come to places that do things certain way, and then you go to another place, and it doesn't make sense because there's a kind of different paradigm is being used for programming. So that's both strength and weakness of the language. So this is one caveat that we need to be mindful of. But there are resources both online and in the software direct, either that github.io or that page is not really that well updated, the download passive, the current version, or straight on GitHub, github.com/Super Collider.
I'm not sure whether it was articulated that the Super Collider is free.
Super Collider is
That's
free.
very
It's an
important.
software.
Information.
It's free to download and use, and also and it's being actively developed this year. I was not maintaining it, but and there are a few other people.
Yeah, what makes the big difference with the other applications? So you have to code it, you have to program software, Pro Tools, and so on. It's more similar to Max environment because you are programming, you are building up your own environment, your own system.
Yeah, comparing to Max is it's more abstract because have the visual representation. You can make it, but you need to make it yourself. So it's not given to you. What's easier instead is that making layers of abstractions it's in a way easier because you don't have to manage it's already abstract code, and you can kind of embed one piece in another piece. More arguably more easy for certain kind of work. So it's a comparing to like Max or pure data.
There are several solutions with this particular program. I think
Yes.
another guy, it's Yuri Bulka, he's from Lviv, but when we are talking about online, it's 3 o'clock in the night.
Yeah.
So that's another. I think this is also the certain question to our students after a certain block of action. So in many cases, the coordination is that with it to follow up this course, then we are helping, in a way,
Yeah,
what is the
absolutely.
best.
There is also a forum, scc.org, where users exchange ideas. If you find an actual blog in SuperPHP, we do need. So yeah, I invite everyone to get into it. It takes a little bit of time to have some idea what's going on, but then you'll see all these resources, the forum, these tutorials, where you start learning and exploring things, and you discover that there's a great power in that flexibility that Super Collider offers.
And maybe I should also mention, getting back to the history of the studio, there's also one important member of our team. It's Michał Pawełek, who was really much involved in Super Collider during his PhD and super PhD, which is habilitation, not existing in the US standard, but
Super
yes, but yeah, but he been using Super Collider for complex projects on one of that. That's also another option to check. Even that he's not really working recently on that, but his knowledge is just enough to help. And that's what I mean.
And I'll leave contact information with Marek, but you can reach me through my website or
we should
email.
we should check also the website of the studio, because your email address is there. I'm not sure whether you can write it down and check it whether this is correct or not. If not, then I will change it. Going down with this first, refresh the website and go down with the main. Okay, here.
Sure, that works.
It's okay.
Yep.
Okay.
This is my
So you have the contact
official
with
email
Marcin
from
directly. Are you on Facebook, on Twitter?
I'm not on Twitter. I am on Facebook and Instagram.
Okay.
Not a huge social media user, but I'm there.
Oh, that's great. So
other questions?
So yeah, that's a moment for question, for this long list of questions now.
Everyone gets just 10, so.
I think this is quite clear. It was quite clear, So I have no
That was completely unavailable.
But if we want to, for example, try it at home and want to connect our phones, for example, so how to exactly do this? Because for me, it's
download TouchOS. It's available for Android and for iPhone, for
TouchOS
iOS.
it's a paid application. There are probably other applications that will just send the accelerometer data through OSC. You need to, it's getting unnecessarily slightly complicated because you need to have a basic understanding of network. But in short, both the same Wi-Fi network, like your home Wi-Fi network, you learn the address of your computer. On a Mac, you can do this by holding Option and clicking the wireless sign, and this is where it shows you what's the IP address. You can also find it in.
In fact, we missed also the what I suggested. So to build up your own local network on your computer, because then it's more safe.
But again, this doesn't always work.
Yeah, I know.
You need to have Mac and iPhone. This is for playing for any device.
Because this is dedicated mostly for some sensors for use with sensors. Or
this is
the
communication, just the basic of the network.
Yeah, but I'm thinking about super collider. And if it's dedicated right, mostly to control some sensors, right?
Not really. What people mostly associate the super collider with is live coding.
Okay.
Is making code that generates. This probably is more use, but it's a very flexible environment, and I am for changing that live processing from the motion sensors.
Making sound not with your computer.
Messages to this address, so whatever address, 1045, in my case, this address. What's not apparent at the very beginning, you need to know the port that super collider is listening. And that port is 57120. We can
numbers.
It's a comment to check for it and see language port. I think go to Unity communication. Yeah, that's unfortunately a little bit very. What happens if you search for OSC communication? Oh, okay, this OSC communication is required. So this would be a good place to start and searchable. But if you look for OSC, it shows you how to receive and send messages. But again, the port that it's open is buried somewhere in here. You can open any. The idea is that IP address is like a street address. Port is like that. So if you know the port that the application is listening on, you specify that port in your sending.
You arrange this.
And that connection will just start once you start your application. The data will flow. So complicated, but once you have the basic.
We've got a question from Yuri Bulka from Lviv. Which is, I'm curious, what is the currently recommended way of running SuperCollider on Raspberry Pi? Post graphical UI.
What depends on? What was the question? What the
wait once more. That's how I stream on. and cause C supercollider lung depends on graphical.
Usually trying to, it's an issue with the build system. I didn't need it, but I also have limited experience with Raspberry Pi, so I cannot really answer this question. I was looking at it. I think I have a. I think it's a thing that we could discuss over one of those channels, either on the SS come up. So yeah, it's an obstacle right now because it's in theory it's doable. At some point it got broken, unfortunately, and then we need to fix it. So yeah, it should be possible. I'm not sure what needs to be changed exactly. You know, developers, so reach out, get in touch, and we'll try to do something about it.
Great. Okay, I make a zoom of your face. Yuri said thanks.
Best I can do, but I was actually looking at it, so it's I think it should be fixable.
I recommended you to get a direct communication between Yuri, which was several times here. He was on Gaude Polonia residence here, but you were already in US, so yeah, it was coming several times during our regular exchange between Lviv Academy of Music and our studio. So that was the point, and we're still running several things like Pandemic Media Space. You got it. He was also part of this, and also part of the coding. And his project is really amazing, following the COVID data. Still, the code is still available, so you can still use it. So thank you very much, Marcin. That was really great. It was really amazing to have you here. Even that you are flying back to the US tomorrow. We are in contact. Yeah, we are in touch very much. I dla Państwa and the others on the net, next lecture is by Jeremy Wexler, our Fulbright resident, next Friday, so January 14 at 12 o'clock. We have already we started active guest lecture in our studio. He will talk, among others, about life. He's a really high expert of Ableton Live, but also about his projects. He presented them during the Spectrum conference already in October, and during the Audio Festival. He's now on the way to run the piece for orchestra and electronics. So there will be quite big variety of different topics in this lecture. Dzięki wielkie. Thank you very much.
Dzięki.
Super. Zwykle mamy nasze wykłady, które są półtorej godziny, więc tutaj się jakby zmieściliśmy w tym naszym wiem, że Piotr z kolei ma bloki troszkę krótsze i od 12 zacznie następne. Jeżeli ktoś z Państwa jest w ogóle zainteresowany takim podmiotem, ja się nazywam Marek Kołoniewski, łatwiej jestem do znalezienia na Facebooku, w sieci, no i prowadzę to studia, także jest bardzo dużo różnych aktywności, łącznie z naszymi regularnymi spotkaniami, w Paweł Group Lab to jest takie środowe spotkanie, bardzo luźne, nieformalne. Spotykamy studenci, ale też wiele przyjaciół z miasta, z Wydziału Intermediów się spotykamy. Od 2012 roku, od lutego, co tydzień we środę o 20. I od 6 lat gramy serię muzyki improwizowanej pod nazwą Playrec. Ostatni był numer 300. Trochę instrumentalistów do nas dołączyło z Wydziału Instrumentalnego, także zapraszamy serdecznie. Jutro o 20 tutaj. Tak, już spotykamy tutaj. No ta szkoła jest mniej restrykcyjnie ograniczona, co się czasami mnie trochę martwi. Powinienem tak mówić do Państwa w ten sposób, mimo że jestem trzykrotnie wyszczepiony, ale ostatnio bardzo dużo jest
przypadków jednakowych mimo zaszczepienia, no więc dlatego jedyne co nam pozostaje to się zabezpieczać cały czas. Także zapraszam, to jest też takie bardzo ciekawe doświadczenie, bo to naprawdę nie trzeba być studentem akademii, nie trzeba grać na instrumencie, można być kompozytorem, teoretykiem muzyki, żeby dołączyć do tej grupy. Paweł wie, bo był kilkakrotnie częścią tych spotkań. Wielkie dzięki. No tak jest. Zamykamy stream. Tak, bardzo proszę, serdecznie tutaj. Tutaj o godzinie 20. Jutro. Proszę bardzo. Olena Ilnycka napisała dziękuję. A ja napisałem dziękuję.
Panie Paweł, jeszcze chwilkę mogę? Jasne, jasne. Dobra, no to ja się tutaj...
Super, to ja pędzę do siostry, którą zapytam o 12, ale